Okay, good afternoon, ladies and gentlemen. These are the diehards. We have to keep our blood pressure and blood sugar levels up at this time of the afternoon. So thank you for sticking out for Industries Day, and now we're going to start with our Industry Deep Dive session. So what I'm going to do is introduce to you the moderator, and then the moderator will introduce his panel. And then we'll finish by 4:30, and then we're going to roll in. If those that are interested, the next session is basically a startup pitch session. So we're going to have like 9 companies come up. They're going to do their pitch, and we're going to have a line of judges that are going to kind of grill them and decide, like, are they going to be in, support these companies or not. So a little bit of that, venture capital pitch session flavor. So I'd like to introduce the moderator. So for this industry deep dive, we're going to have Joe Landon, who is Lockheed Martin's Vice President for Advanced Program Development in our civil and commercial line of business in Lockheed Martin Space Company. He's been with the company now almost exactly 1 year, so congratulations on your 1-year anniversary. And Joe he has a great background. He has a background in aerospace engineering and also a Harvard MBA. So he comes really with this great view on the technical side of things as well as on the business side of things. And so what Joe is going to do is basically moderate a panel of some interesting companies and do some deep dives in terms of the dynamics and latest results and news from these emerging companies. So without further ado, Joe, I'd like to introduce you, ladies and gentlemen. Thank you.
Thank you very much, Robbie. Thanks everyone for coming. My name is Joe Landon, and I'm the Vice President of Advanced Programs Development for Commercial Civil Space at Lockheed Martin. I'm glad you joined us today for this session, which I think is going to be really interesting and fun. It's my pleasure to host this session where we're going to cover a series of industry deep dives. And what we've done, we've selected a group of entrepreneurs from some of the leading commercial space companies to talk to you and to share some information about what they're up to and some of the projects they're working on. We tried to do a little bit different format, so it's not going to be a panel today. We're going to do a series of individual TED-style talks from our speakers today. So I hope you enjoy the talks. I'm looking forward to them, and without further ado, I'll introduce our first speaker. Peter Beck is the founder and CEO of Rocket Lab. Peter is an acclaimed scientist and engineer, having been awarded a meritorious medal from the Royal Aeronautical Society for exceptional service, and the Cooper Medal, presented by the New Zealand Royal Society biannually to those deemed to have published the best single account of research in physics and engineering. Peter's company, Rocket Lab, provides frequent, reliable, and affordable dedicated launch services for small satellites. They also recently announced their intentions to provide launch services to the moon. Peter will be speaking today about small satellites, big future. Welcome, Peter Beck.
Brilliant. Thanks very much. It's an honor to be able to talk to everybody today. So Rocket Lab, we're a launch vehicle company. We build small launch vehicles for delivering small payloads to orbit. This is your average to large size spacecraft in 1990, and this is a spacecraft of today. This spacecraft has 4 high-resolution cameras, communication systems, and a whole suite of sensors. Obviously, it's not as capable as the previous satellite, but I think you kind of get the deal with what's going on here. The Moore's law has been applying itself to spacecraft, and things are shrinking in an incredible way. But capability is also not shrinking but growing. Just want to show a little video that kind of summarizes the company. So the Electron platform, so we just completed our 9th launch a few days ago, actually, and we're very proud to boast 100% mission success for our customers. Not only that, we've delivered to date a total of 40 satellites to orbit, the ride that we provide is incredibly smooth, and we like to think easy for our customers as well. And one of the things about the vehicle is the orbital insertion accuracy. So, we insert to an average accuracy of around about 1.4 kilometres. So it's not only is a smooth ride, but we try and get you exactly where you want to be, which is really the critical thing for a dedicated small launch vehicle is making sure that you get to exactly the orbit you need and exactly the time frame you need, and very, very precisely. A little bit of a recap of this year for Rocket Lab. So we built a couple of factories. This is one of the factories, and currently that factory is producing one rocket every 30 days. So every 30 days a rocket rolls off the production line. The factory is designed to be able to produce one rocket every week, and we're slowly ramping that flight rate and that build rate up. We also introduced this year our attempt for reusing Electron. So this is a very challenging thing for a small launch vehicle. Obviously, there's not the mass margins that you have available in a large launch vehicle. But Flight 10, which is the next vehicle that's on the pad, has some pretty major block upgrades, and we'll be attempting to go pretty deep with that vehicle for our first recovery attempt. So keep an eye on that flight. It should be a good one. And then also we're building a new launch site in Wallops Island, Virginia. Thank you to the NASA team and the Mars team for supporting us there. We started driving piles in that launch site in January, and it will be operational and certified in December. So it's a pretty quick build for a launch pad, and our first mission will be out of that pad early next year. And one thing I want to spend a little bit of time on is the sustainable and responsible use and deployment of objects in space. For us here at Rocket Lab, this was a fundamental ethos that was baked into the original design of the vehicle. We see a lot of especially a lot of small launch vehicles in development, and a lot of drive to put a lot of mass on orbit, which is hugely exciting and really important. But we shouldn't lose sight of the responsibility when we do that. It's great to put satellites on orbit, but it's not great to leave lots and lots of rocket junk behind. So we kind of architected a way to go to orbit that is a little bit different from the traditional standard. And I'll use this animation to kind of explain here. What we do is we put our second stage into an elliptical transfer orbit, and we have this thing on the top called the kick stage. You can see a little photo down on the left there. And it's got its own propulsion system and its own comms and everything. And we separate that off the second stage, and we leave that second stage in a transfer orbit. At the moment, our second stages are staying on orbit for about 4 weeks before they burn up. Then we have a little propulsion system where we burn and circularize the orbit and trim it. That's how we're able to get such high orbital insertion accuracies. And then we deploy the spacecraft, and because we have our own propulsion systems, then we can do a deorbit on that stage as well and leave nothing behind except the spacecraft. And that should be the standard. We should, as launch providers, we should only be leaving the spacecraft behind, the bit that's doing the work, and not leave our rockets behind, which I think is really, really important for us anyway. And we also announced this year what I'm personally the most excited about of all of our programs, which is our Photon satellite. So it always seemed bizarre to me that we would have a rocket, and then literally 6 inches from our rocket we would have a spacecraft with largely the same amount of equipment or same equipment that was in my launch vehicle. So we kind of stood back and said, what are the barriers to putting innovation and payload in orbit? And one of the barriers is obviously launch, and we think we're addressing that. The second barrier is you've got to go and build your own spacecraft bus. And we see many startup companies living and dying by building their first bus, where really that shouldn't be any concern at all. What we should really be concerned about is how we innovate on orbit, how we get our payloads on orbit. Everything else behind that should be a commodity. And that's what we're trying to do here with the Photon bus, is the Photon bus enables you to come just with your payload, just with your sensor, just with the capability that you want to create, and we take care of everything else. And we announced at this conference actually a partnership with KSAT, so now we can do launch, satellite, and ground through the partnership in KSAT. And Everybody just needs to worry about what capability or what sensor they want to put on orbit, and everything else can be taken care of easily. I want to end on this slide. It's a rather bizarre slide to end on, I appreciate. But I want to tell a little bit of a story behind this. So, and this will age me, but when I was at primary school, about 10 years old, our school had a computer, not dissimilar to this one, and attached to the computer was a little black box. And that little black box was a dial-up modem. And every Friday we would sit down and we would dial up this modem, and we would send what is now referred to as an email to another school in America. And we thought that was just the most amazing thing possible. And I often wonder what would happen if I traveled back in time to my 10-year-old self and explained to him all of the things that were going to come because of that black box. And you would largely think that would, you would think that most of the things that I would be saying would be improbable. And the reason why this story is important is I believe that we have just sent our first email to space. This is largely where we're at, and there's so much opportunity and so much innovation that's yet to come. I think we're really witnessing the beginning of the internet and with respect to the space age. And I used to wake up every morning wishing that I was born in the Apollo era, because I figured that was the pinnacle of space. That was when the most amount got done. But actually, I think I've changed that thought, and I think actually this is the era that the most amount and the most, I guess, humanity-changing projects can be completed. So thank you very much. I'll leave it at that.
Okay, thank you, Peter, and congrats on getting Rocket Lab off to a truly impressive start. So we're going to continue with our series of founder and entrepreneur TED Talks. Our next speaker is Takeshi Hakamada. He's the CEO and founder of iSpace. iSpace is a company developing robotic spacecraft technologies to build landers and rovers to provide transportation services and perform exploration missions. Takeshi earned his Master's of Engineering from Georgia Tech, and he previously worked as a management consultant. Today, he'll speak to us about incorporating the moon into the Earth's economy.
Thank you very much for introduction. It's my honor to be here to speaking about iSpace. This year is very important year for me because I'm inspired by Star Wars. This year is the last episode of Star Wars. And most importantly, this year is 50 years after Apollo mission, Apollo 11 landing. And I have a big vision incorporating Earth economy and then the moon economy into one ecosystem in the future. I'd like to begin with the videos explaining our vision.
The universe's newest city is home to 1,000 people. And every year, over 10,000 come to visit. Only 20 years ago, this city didn't exist. It's the result of pioneers sending rovers, then discovering water. The hydrogen and oxygen separated from water becomes energy, creating the foundation for a fuel station. And with the fuel station came scheduled flights, followed by settlers. Soon, settlers required more diverse skills, attracting new specialists for construction, steel, communications, energy, transit, agriculture, medicine, and more. People travel from far and wide to see this new city. We call it Moon Valley. The moon is the new staging ground for your next level business. Expand our planet. Expand our future. iSpace.
In order to create such a world, we believe we cannot do it by ourselves, even only the existing space companies. We need to invite many of the players from terrestrial industries, not only space industry, like mining, transportation, automotive, energy power, telecommunications, health, and then food, and then consumables. Especially if we start thinking about humans existing in this space, we need such players. And then we want to create this world with such players. However, it takes time to create such a world. So even though we have ambitious visions, we have logical steps to approach this vision. The first step is to create transportation system, high-frequent, affordable transportation system to the lunar surface. And then we're going to find out resources on the moon, especially water. And then in the second phase, we're going to unlock the water resources on the moon and then provide propellant created from the water, hydrogen, oxygen. And if we start providing energy and the propellant to the other players, I think we can approach to the world where human beings live in space. And as a first step, we need to develop a transportation system, and we need money. So we raised about $100 million from investors 2 years ago, at the end of 2017. This was our largest Series A funding in Japan and then globally in the space industry as well. Using this money, we are developing two hardware. The one is lunar lander, and then second is lunar rover. Our concept is small, low-cost, and high-frequency hardware and transportation system. We are developing lunar lander, which can deliver about 30 kilograms payload to the lunar surface several times per year. And then for rover, we have been developed smallest, lightest weighted rover during lunar X-Prize. The weight of the rover, mass of the rover is just 4 kilograms. And then that can deliver and then deliver a small sensor payload for the scientific exploration or the resource exploration in the future. So we've already planned 2 missions at the beginning as a technology demonstration. We called Mission 1, Mission 2. And then we are planning to launch first mission in 2021, and the second mission 2023 with a single rover. And then after such a demonstration, we enter the commercial transportation service from mission 3. And then we expect to do transportation several missions per year. We are a for-profit company, so we have to create revenue from our service. We have 3 business models for the first phase. The one is payload delivery service, like FedEx to the lunar surface. And the second is lunar data service. The data obtained on the moon or during the mission is critical for the space agencies or the other commercial players who are going to enter this market in the future. And then also the video image data can be utilized for the game or VR or entertainment business. And then third business is very unique for us. We call partnership. This is the platform for the non-space company to enter this space industry. We open the opportunity for the company who have technology or the business to be utilized for the space market in the future. And they also leverage their participation using advertisement merit. And then I introduced first two missions, 2021-23. We called these two missions as a Hack to R program. Hack to means white rabbit in Japanese. Japanese think there's a white rabbit on the moon. And then we have many of the corporate partners to support these missions. These 6 companies currently committed to support our missions. They have individual support like a technological support or business support for this mission. And then also we are working with Draper Laboratory and then General Atomics space flight industry to support NASA's future lunar missions through NASA commercial lunar payload service. Our team, Draper team, is one of the 9 providers selected for the CLIPS missions last year. And then we are very looking forward for supporting NASA's missions. And then now we have about 100 employees living in Japan, and then Luxembourg and the United States. And then 70% our engineers are working on lander development, rover development, and we are still looking for the experienced engineers. So if you're interested, please apply for our job post. Thank you very much.
Great, thanks, Takeshi. We're really fortunate to have these successful entrepreneurs with us today, and such a global group of companies. Every one of the companies that we're going to hear from today have a global presence in multiple countries, and that's, of course, the case for our next speaker as well, Nobu Okada. Nobu Okada is founder and CEO of Astroscale. And Astroscale has offices in Singapore, Japan, the UK, and the US, so another global company. And is developing technology in the aid and removal of orbital debris through the provision of end-of-life and active debris removal services. Nobu is a graduate of Purdue University and previously spent time at both McKinsey & Company and Bain Capital. So let's welcome Nobu Okada from Astroscale.
Hello, everybody. It's a great honor to be here today, and thank you very much for a great introduction. I'm Nobu from founder CEO of Astroscale. When I was 15, I joined space camp in Alabama State, and I met with the Japanese first astronaut, Mr. Mamoru Mori. He gave me a handwritten message saying, "Space is waiting for a challenge." This ignited passion for space in my mind. Since then, I studied hard. But unfortunately, my career had nothing to do with space for a while. When I was turning to 40-year-old, I suddenly remembered this message, and I had a passion for space, and I really want to have a job in the space industry. And then I attended a couple of space conferences in the world to see what are the hot topics. It might be a moon exploration, Mars exploration, new rocket, but I found the hot topic was this: space debris. All the red dots are space debris, and can you see the white dots? These are the real operating satellites. More than 30,000 of the large objects are traveling around the Earth, and the density of the space debris have reached to the critical level where chain reaction of the collision can happen at any near future. And we know over the next 5 to 10 years, the density will grow much faster. So we have to remove large objects now before they get smaller, they get fragments. Otherwise, space will not be sustainable anymore. I was thinking, who should solve this issue? This is a critical issue because our daily lives really depend on space technologies. And I found there is a specific committee in the United States, United Nations, UN Corpus in Vienna. And they had been talking space sustainability issue for a while. And it's great news because there is a place, organization, where countries will agree on rules and directions. But I also found UN cannot create solutions because of the nature of this organization. I also found there was nobody, no organization had a solution to remove debris. And then I decided to stand up to create a new company to remove debris. Looking at a highway, if there's a broken car on the highway, AAA comes and tow the car to make sure highway is always smooth. To do that, there is a technology like a crane, rules like a policeman, and business like an insurance model. For satellites, spacecrafts, orbit is a highway for them. So we should create this kind of model in space, like a AAA in space. We have to create a business model, technology, and rules. So that's why Astroscale was founded six and a half years ago. We are not, actually 3/4 of our team are engineers, but we are addressing three things simultaneously: business, technology, and regulations. Each of them are quite complex for space debris removal services, but we have to solve these three together, otherwise we cannot clean up the space. We started with nothing. I didn't have much money. I started by myself, but now we have 100 people in Japan, UK, US, and Singapore. And we gather for purpose. These are great engineers. And we raised $140 million US. That's a good start for us. Next year, we're going to have the world's first end-to-end debris removal mission, ELSA-D. We will prove the technology required for debris removal. Our chaser satellite, servicing satellite, will capture the tumbling object in space and bring them down to the atmosphere and burn. I will not get into details about this ELSA-D mission because we have 9 speech sessions opportunities from tomorrow during this IAC. And we talk about technologies and business case. So we're a profit company. So we are creating business and regulations, how complex regulations are and how we are tackling on that. So if you are interested, please attend, check Astroscale and attend these sessions from tomorrow. This is the only slide I want you to remember. 70 years ago, there was nothing, no debris. But now, like this. There's a huge difference between environmental issue here on Earth and up in space. For the Earth environmental issue, we do not know to what extent human beings contributed. But for the environmental issue in space, we know for sure it's human beings alone who contribute this pollution. So it's human beings who should solve this issue. And time is ticking. And we do not leave the unsustainable space to our kids. So we have to solve now. Thank you very much for attention, and looking forward to talking with you. Thank you.
Thank you, Nobu. So we've got one speaker left. And it is from, our last company is from Planet. And the thing that really is remarkable about these 4 companies is that together they have been extremely successful at raising private financing. By my calculation, almost $750 million between these companies, which is among the best or highest fundraising companies in the industry. So it's a real privilege to have them here with us. And Planet is certainly has been strong in the financing side as well. We're joined today by Chester Gilmore, who was one of the early employees at Planet and currently serves as Vice President of Spacecraft Development and Manufacturing. Planet's an Earth observation company that has designed, prototyped, qualified, and launched more than 18 different versions of its Dove spacecraft. And they can produce these spacecrafts over 25 satellites a week in what is truly a revolutionary production system, which I hope we'll hear about from Chester. Prior to joining Planet, Chester was helping Las Cumbres Observatory Global Telescope Network build and operate a longitudinally deployed global network of fully robotic, autonomous 1 meter and 0.4 meter telescopes used for scientific research. Please welcome Chester Gilmore from Planet.
Thank you for that nice introduction. Hello. Hope everyone's having a good Congress. Okay, so Planet Labs. It's really a pleasure to be here and get to talk about Planet and our mission. I really love what I do, and I love what Planet does, and I count myself incredibly fortunate to have gotten to be a part of this. If you don't love what you do, please also come talk to me afterwards. We're hiring in almost all areas, so I'm always happy to talk and send me an email. I'll give you my card. Okay, that's done. So here's what we're doing. We want to see change and change the world. Our mission is to image the whole world every day. Check. And then also make change visible, accessible, and actionable, which is what we're currently working on very, very furiously at the present moment. So this should maybe give you an idea of our constellation design. We're currently operating 3 different classes of satellites. There's the Dove spacecraft, of which we have somewhere over 100 in orbit operational, and we have the Terabella Skybox satellites, which are sub 1 meter assets, and then we also have the other satellites, which you'll hear about in a second. So Rapid Eye, PlanetScope, Dove, and the SkySat satellites. So this is our constellation. Yep. This was a new factory that we deployed in San Francisco. So we currently talked a little bit about this, but our design when we started building and designing hardware was not to build the perfect satellite. It was to build the perfect system. With that, what we essentially started doing is we realized, okay, we need to, in order to monitor the whole Earth every day, we're going to need to produce lots of these at scale. But it's more than just building a lot of satellites. We also need to design a operation system that can autonomously operate the spacecraft, and then a data pipeline that can get the spacecraft, get the data down, ingest it, orthorectify it, process it, and then build applications and data on top of that to help drive actionable change about what's going on with our planet. So to do that, essentially what we did is we took a systems approach where, okay, here's what we're trying to build at the big picture, the 10,000-foot ceiling, and we didn't want to allow any subsystems, lagging maturity to impede our progress. So what that meant very, very early on, we made decisions based on things like a blurth is better than an Earth. And what that means is a blurry Earth is better than no Earth, right? Make no mistake, our intention is not to ship hundreds of satellites that are out of focus, but the intention was to make sure we were prioritizing the mission and the system above any small subsystem requirement to allow us to move the mission and the company forward. And as a result of doing that, what we developed is a way to design, iterate, build, and launch spacecraft that's really. It's not that uncommon in consumer electronics, but it's pretty uncommon in the aerospace industry. So this is our Dove satellite. That's a copy of the image of one of our spacecraft. Okay. Now we have the SkySat, which produces 0.72 meters resolution from space. And, the hardware is interesting, but, we have some time. There is a timer somewhere, and I don't want to run over. And I want to really get to the whole point of why we're doing this, to get to the use cases of the data and what we're doing with our data today. But this gives you an example of some of the SkySat imagery that are coming down, and then really the end-to-end system. And this is what I talked about. In Planet, we've been very fortunate to be pretty vertically integrated, which means we've done everything. We deployed our own ground stations. We designed our spacecraft. We designed and built the software for the spacecraft. And what we've essentially developed is a avionics and a satellite platform that allows us to very, very quickly build and scale on other missions. And then surprisingly, or maybe not so surprisingly, but I would say now 70% of our company are not hardware or spacecraft engineers. 70% of our company are people who are working with the data products, working in analytics, in pipeline, trying to help our business and our customers solve very, very real challenges that they have. So really the focus is on the WebGeo platform for analytics, and this is where most of our energy is going. We do have an unprecedented data stream. We will continue to build and develop other versions of our hardware, but the real end goal is to make sure we can deliver more data, quicker to the end users to help them solve problems and to help, produce actionable change. Okay, so, delivery, insights, and imagery, this is really what we're about. And as Will Marshall, our CEO, likes to say, it's essentially a minor Apollo project that we've taken on at Planet. I think if we knew what we were really getting into 8 to 10 years ago, I don't think we ever would have bit this off. But sometimes, when you get a bunch of smart, bright engineers together in a room, I think Rocket Labs, is a great example of that. You don't really realize what is impossible, so you just go for it. And that's essentially what we did, and I think we've benefited from that tremendously and from the, So why does daily cadence matter? It's very, very important to be able to produce change detection at scale. It allows us to reduce false positive and noise, and really what we want to do is we want to enable accurate change detection, so we're not spending all these man hours searching through tons of data. We want to have efficient tasking of our higher resolution assets, and we want to basically fulfill higher business objectives at a more rapid cadence. This is an example of what our data can do, looking at IDP camp growth in Syria. So here you can see a series of imagery from June, July, August, October, November, all the way through February, and you can look at automated, and this is some of our internal change detection classifications where we're actually detecting roads and buildings as they're evolving and growing over time. This is an example of how this works. You can see the imagery at the bottom left, and then on the other side, and then you see what our algorithms do is they look at in our machine learning, the imageries come in, and then we run our change detection algorithms against it, and then we produce indications of where there's change that tells our partners, okay, something moved here that's really, really important. We need to take a closer look at it. This is an example of ground truthing in San Francisco, California. So this video is going to play out, and you're going to see, I think it's going to play out. Yeah, okay, here we go. So you're going to start to see Google Maps, and then you're going to start to see our imagery, and then you're going to start to see the roads, buildings, change detection algorithms laid over the top of that, where you can see what we have and what's changed. And again, this can happen at a global scale, and this is an example of essentially some examples of that. Okay, so this is an example of object classification. So you can see wind turbines, well pads, airplanes, oil tanks, feedlots, swimming pools. These are all the types of image classifications that our teams are currently working on training data sets against, so we can figure out where are the swimming pools coming up, where are the wind turbines, and there's a lot of work being done internally, both by Planet and also by our partners, to really focus on how we can progress this forward, because with all these data sets and all these new sources of data, data. It's, data gravity is important. It's important to get all the data in, but it's also important to try to help our business partners and help all of you figure out, well, what's actually going on in the Earth on a daily basis. And this is going to become even more important as more sources of data start to stream in. Here we're looking at some harbor activity, and you can see where we're running ship detection and change. So what's happening is our monitoring missions are imaging the whole Earth every day, and then it's basically producing heat maps and kicking up indications and warnings where we need to task our high-resolution assets, and we need to indicate to some of our customers, hey, there's something going on here. Maybe you should look at this. So here we see ships sort of coming and going. Road construction is an early indicator for deforestation. This is super important work that the team's doing, looking at, these are actually, what we're seeing here is the formation of illegal logging roads. So these are roads that are coming up in the Amazon that weren't supposed to be there, that all of a sudden our data is tracking over time, and you can see what's happening. Those trees are not supposed to be removed where they are, right? This was in the news not that long ago, but this is one of our image that we captured and published a few hours after this event occurred in Semen, Iran. We published this, then DG published, and then I think our president tweeted an image shortly thereafter. This was a really interesting photo where we actually caught the trail after the launch point from the Hodu Peninsula. This is Marsh Harbor. This is before. Let me go back to that so you can kind of see the before and after the hurricane, right, that came through. So you can see flooding. You can see buildings that were here that are no longer there, right? So this is some examples of the use cases of our data. So it says questions, but we don't have time for that. I'll stick around here. If you have any questions at all, you want to talk to me. We've got some other members planted in the room as well. We'll all kind of hang out if you have any questions about what we're doing. So thank you so much.
Great. I want to thank everyone for listening. I was really impressed by these presentations. These 4 companies really represent the best of the future of the space industry. And it just was a privilege to be up here just to introduce these companies to you today. So let's give another round of applause to our speakers today. Thank you very much. And I'm Joe Landon from Lockheed Martin. Please stick around for the startup pitch session, which will be set up for right after this. Thanks.